In this nutshell, you get a chance to practice your programming skills. You will write the code for a transmitter and receiver for a car door lock, and you will base that on a structure diagram. And if you do find this video useful, please like and subscribe. For this problem, you are writing the code for a remote car key lock. So you're designing the code for the car key itself, the actual button that you press. The key communicates to the car via Bluetooth, connected to USART 2. The transmission is 9 bits. Bit 8 indicates the command, 1 is lock, 0 is unlock. Bits 7 to 0 contain the key code. So while the lock or unlock button is held down, you will transmit the 9-bit code with the 8-bit based on which button is pressed, and while the button is held down, flash the LED every 10 milliseconds to show the key is transmitting. So there's the inputs. The lock button and unlock are on pin H4 and pin H7. The LED is port C7, and we are going out the UART 2, which is on port H1, and format is odd, 9 data bits, 2 stop bits, and a 9600 baud rate. So now pause the video and try to write the pseudo code and the structure diagram for this problem. So to understand this problem, we must realize that we can send 9 bits of data in a frame. But because the microcontroller is 8 bits, the 9th bit is held in these, for the transmitter, is held in bit 0 of UCSRnA in this case, and the receiver is held in bit 1. So we're transmitting, so the 8th bit is going to be held in TXB8 2. So the pseudocode, we set up the GPIO and the USART for odd parity, 9 data bits, 2 stop bits, 9600 baud. The frame is 9 bits. Bit 8 indicates whether to lock, a 1, or unlock, 0 the car. Bits 7 to 0 are the key code. If either button is pushed, wait for UDRn to become empty. If the lock button is pushed, set TXB8, else clear TXB8. Then we load UDR with the key code. Now, loading that with the key code will start the 9-bit transmission. So we must, first of all, before we transmit, always set the bit 8 here before loading UDR. And finally, we toggle the LED. And we can see here the actual structure diagram, set up USART GPIO. While 1, if either button is pushed, we wait for the transmit buffer to become empty. If the lock button was pushed, we set the command bit to a 1. If it wasn't pushed, then it must have been the unlock button pushed, so therefore we clear the command bit. We then transmit the key code and lock command and pulse LED. So now pause the video and see if you can write the C code from the structure diagram. We can see the code derived from the structure diagram. First off, we're using delays, so then we need to include the delay library and define the CPU clock frequency. We can look at the defines for the transmit buffer flag and our inputs and our outputs. We have the setup routine shown down here. I'll explain that shortly. We then have our transmit key code, which is 00001111. We call setup and we start in the while run routine. Now this statement here is an if. I could have used a while, but I've used an if. Now this is a byte-wise OR, which means that if either the lock button is pushed or the unlock button is pushed, then we'll go into this part here. We wait for the transmit buffer to become empty. If the lock button was pushed, we set bit 8, else we clear bit 8. And then we load the key code into the data register. This will then start the transmission. Then we have the LED on, LED off. And we will repeat the while one, and that will keep on transmitting while those buttons are pushed. Looking at how we configure the registers, first thing we look at is that we see the 2 shown whenever we access these registers. That just means we are configuring USART 2. So looking at the first one here, transmit buffer empty, we're looking at the UCSRnA register, and we are looking at this flag here, bit 5, and that's a flag to tell us the data register is empty. We can show that shown here. Looking at the baud rate setting, we can get the value, the baud rate from the table. We're using 9600, so 51 is loaded into UBBRnH. Now, looking at the UCSR2B register, I had that shown here. Bit 7, 6, and 5 are interrupts. We're not using that. Bit 4 is receiver power. We're not using a receiver. Bit 3 is a transmit power, so we're turning that bit to A1. Now, finally, bit 2 is used with these other bits shown in UCSRC. So we have UCSZ2, UCSZ1, UCSZ0. They should be set to 9 bits, so 1, 1, 1. So in the B register, we set that bit for A1, as shown here. And looking at the C register, then these 2 bits here are also set to A1. And finally, looking at the UCSR2C register, we've already described these 2 bits here, which are for the data size. So looking at 2 bits, 7 and 6, they set the mode of operation. They should be 0, 0 for asynchronous, as shown there. We are running odd parity, so that's these 2 bits here, 5 and 4. They should be 1, 1 for odd parity, shown here. 2 stop bits, so that should be set to A1 there. Finally, the transmitter is going out on PH1, so we set that for an output, and the LED is on port 7, so therefore we set that for an output as well. The next part of this problem is to write the C code for the car lock receiver. So we still have the same USART, same serial format, odd parity, 9 data bits, 2 stop bits, 9600 baud rate. Read through this paragraph. I've written it in one paragraph, but you need to break it down into stages for it. Basically, you're looking at the receive code. If it's correct, if the command is to unlock the car, unlock it unless the car is already unlocked. And if you are to lock the car, lock it unless the car is already locked. But read that instruction. You should test the parity bit because we're using parity. And to avoid double triggering or debalancing, you must wait until the key transmitter finishes its current transmission before responding to a new command. So pause the video and then write the pseudo code to start with, put that in a more structured idea, and then write the structure diagram from this problem. So pause the video now. The solution for this problem is not that simple. It took me quite a few iterations to come to a final solution, and that's why it's good to write the pseudo code to start with. Just get an outline of what you want to do. Then you put it into a structure diagram to make sure that it's in a nice, clear structure. Things to note: if you are using 9-bit data frames, the 8th bit is stored in the RxB 8-bit in the USCRB register. And you must read this bit first before reading the lower 8 bits in the UDR register. Also, if you're checking the parity flag, you must check the flag first before reading the UDR register. Those are the 2 points you need to understand. Have a look at this. This is an outline of the code. We set up the GPO and USART 2. Bit 8 indicates whether to lock or unlock the car. Bit 7 to 0 are the key code. And have a look at the structure here. Pause the video if you need to read through that. This is now translated into a state machine, so we can see the whole thing shown here. This is if we're receiving data. We check the key codes, and then we will lock or unlock the car. Otherwise, we will wait for the transmission to end, and then before we allow a new transmission link to occur. So look at the structure diagram, pause the video, and see if you can write the C code from the structure diagram shown here. I have broken the code up into parts to make it more clearer to see. So our define and include statements are shown here. We are using the delay routine, so we must specify the clock frequency. We are looking at the receive buffer full, which is bit 7 here of the UCSRnA register, and the parity error shown up here, which is bit 2 of the same register. The indicator is on port B, the lock is on port C. Now, we want to know if the car is locked or not, so we are going to use pin C to look at the state of the lock. And finally, the beeper is on port D bit 5. Looking at the main part of the code, we have the defined receive key code 0F. We have the variable setups here. And then we have the while one loop. So if we see here, if link is finished, if it's finished, we will start doing this bit of code. If the transmission is still going, then we come into the else. We delay to let the transmitter send some more data if it's still transmitting. If we do get more data, we just clear the flag and we come back into the else. When the transmitter finally stops sending data, the link is finished, so then we can wait for the next transmission. In the next transmission, the link's been finished. If we receive data, we check for a parity error. If there is an error, we just clear the parity error flag. If there's no error, then we load in the 8th bit to see if the car is to be locked or unlocked. And then we read the key code. If the key code is correct, then the link is established. If the command is lock car, if the car is already locked, we just turn the indicator on and off. Else we lock the car and flash the LED. Now, if the command was unlock the car, if the car is already unlocked, we turn the indicator on and off for 1 second, else we lock the car and flash the LED 4 times. Now, looking at the configuration of the USART, we first want to set the baud rate. We want to set for 9600 baud. We have a table from the datasheet. We have a clock frequency of 8 meg. Therefore, we load 51 into the UBRR lower byte. Looking at the UCSR2B register, we have bit 4 here, and bit 4 powers on the receiver, so we set that to a 1. Finally, we have bit 2 here, shown here. This is used in conjunction with these other 2 bits to set the data size. This bit here must be set to a 1 for 9-bit data. Looking at the configuration for the control and status register C, bits 7 and 6 are used to select the mode of operation. They should be 0, 0 for asynchronous operation, shown here. We are wanting odd parity, so these bits here, bit 5 and bit 4, should be set to a 1, as shown there. We want 2 stop bits, that is shown with bit 3 here, that should be set to a 1, as shown here. And then finally, we want 9-bit framing size, so these bits here, 1, 1, 1, 1, that was set in UCSR2B, and these would be 1 set for this UCSR2C register, as shown here. And then we want to set outputs for the indicator, the beeper, and the lock. And finally, we have a flash LED routine which will flash the LED and indicator a set number of times. Out of interest, I combined both the transmitter and receiver code into one program, and I'm using the feature on the megaPro board, which is a loopback feature where the transmitter is looped back to the receiver on USART 2. So we can see the code here, and here is our code for the transmitter, and here's our code for the receiver. So we've looked at this code before. If I download this to the megaPro board and have a look at it. So the lock is on PC 0, the transmit indicator is on PC 7, we have the indicator is on the light here, and we have the beeper sounding as well. So if I push the lock button, we can see PC 0 is locked. It beeped and flashed. Now nothing's happening even though we're transmitting data. So if I go and try to lock it again, the indicator comes on, nothing else happens. Now if I go to unlock it, then I push the unlock button here, we can see that PC 0 is unlocked. We had the beep and the flash. Nothing else is happening because we're waiting for that transmitter to stop. If I push that again, so it's already unlocked, so we just get that light coming on for 1 second. So we can see the operation of the car lock, transmit and receive, shown here.